Okay, so we're going to start with just a couple of real quick reminders of a couple things from yesterday. And so start with this one. It just says simplify -2 times the square root of -72. So now talk me through this. What's gonna happen here? Good one. Hey, let's go through that process. No, Lulu, let's go through that process. Grab the calculator. Here's my list of numbers that I want. Okay, I'm looking for 72, so I want a factor of 72. So I'm gonna go over here. 72 would fall right here. So what I'm going to start doing is dividing by each of these numbers until I find one that's not a decimal. So 72 divided by 64 gives me 1.125. That's it. Well, it doesn't matter. -72, whichever. But that gives me 1.125. So that's not a factor. 72 divided by 49. 1.4693. That's a decimal. It's not a factor. 72 divided by 36. That's 2. So 36 is the one I want to use. So what I'm going to rewrite now is the 72 is going to be 36 times 2. Okay, 9 and 8 work, except 8 also has a perfect square factor of 4. So you have to make sure you kind of get it there. When I divided the 72 by 36, it gave me 2. The 36 times 2 is equal to 72.
So you use the number that you use
and what you divide it. Because I got to replace it with something that's equal to it. So 36 times 2 is what 72 is. Okay. All right. So remember, if you have a number next to parentheses or square root, it's always a multiplication. Okay, and the things that I know the square root of 36 is what? 6. I know the square root of the -1 is I. I'm going to kind of put it out to the side there. And then the 2 just has to stay under a square root. All right, and then I just multiply what I can. So -2 times 6, -12, square root of 2, I. So a couple things that I didn't focus on a lot yesterday. I didn't put it out here. If there's a number outside already, then you just end up multiplying it by whatever you bring out of the square root. And the other piece, I always put the I at the end. I think yesterday I kind of put it in the middle on a couple of them before the square root. I always put it at the end and put parentheses around the actual number. And that's more for the next type we're dealing with complex numbers. All right, questions on that? Okay, writing down in that A plus BI, if you can do this, that should be a problem. So let's look at a couple of things for today's lesson. Absolute value. All right, so first question is, what does absolute value look like as far as how do you draw it? Straight up and down lines, okay? So that's simple enough to start with here. So there's 2 types. First type, if you just have the imaginary part of the complex number. Remember the complex numbers? You had this, and this was the real part, and this is the imaginary part. So if you just have the imaginary part, the absolute value is just going to be whatever this number here in the front is. So absolute value in this case equals 5. And so that one shouldn't be too long. Okay? The problem is when you have both pieces. So you have the absolute value of 3 minus 4i, or anything in that form. Here's what you do. Anything in this form of a plus bi, the absolute value is equal to the square root of a squared plus b squared. So in this problem, what's a? 3. What's b?
4i.
Negative 4. B is what's in front of the I, so negative 4. So to find the absolute value, I take the square root of 3 squared plus negative 4 squared. And you can plug that straight into the calculator. I'll actually go ahead and work it out on the board here. 3 squared is 9. Negative 4 squared is 16. Add those together, I get 25, and the square root of 25 is 5. Are we okay with that? Let's you do. I'm gonna put 2 problems up here that y'all kind of work through. Example 1 here. I'll work those 2 out real quickly. Alright, so what's the answer on number 1 here?
3.
And then what y'all get over here?
29.
So, I'll work it out real quick, make sure we're all on the same page here. Everybody get that far?
Yep.
There's no square root of 29. It doesn't have a factor that's a square root, a perfect square.
So if we come out of
So-
decimal, we just it.
Yeah, unless again, like you have something like you've had in the past, like a while ago when we had the square root of 72, we could break that down. And so if you can break it down further, simplify it, then you can. But that one there, 29 doesn't have any other factors other than 1 and 29. All right. Okay, so let's move to another kind. So that's absolute value. So not too difficult for absolute value. The next part we refer to work on is called the additive inverse. All right. All right. This is not too difficult either. So if I give you a number like -6, and I tell you or ask you to tell me what is the additive inverse, does anybody have a clue what I'm asking?
The opposite.
It's the opposite. Okay? And the reason for it is you're looking for the number that I can add to this to where it becomes 0. So the additive inverse of -6 is +6. Okay? Should be pretty simple. Okay, so if I give you another one, let's say this one I give you is negative, no, we're going to do positive this time. I give you 14.2. What's the additive inverse of 14.2? All right, so we got this going on now. I'm learning some algebra too, sort of. All right, so now we're going to look at the complex numbers. See what kind of difference we have there. So if I give a problem like -2 plus 5i. What do you think the additive inverse would be? What? 2 with a -5i? Anybody else got an idea? Does that sound good? Thoughts? Yeah, let's look at this. What do you get here? To get the additive inverse of -6, what we did is we took the negative, the opposite. Like somebody said, which gave us positive. To get the additive inverse of this one, we took the negative, which gives us negative. So what we do is we take the negative, and what happens when you take the negative of this? It just changes the sign on each term. So it's pretty simple too. 2 minus 5i. Okay. If we make this a little simpler and give you the number 4i, what do y'all think the additive inverse is going to be? -4i. All right. Anything so far confusing at all today? No. Good. So now we got a little bit more time. So there's one more type of problem that we haven't done yet. And it's still not hard. It's just combining like terms kind of thing. But some of us, we struggle a little bit with it. So. All right. So here's what I want you to do now. Again, we're going to simplify because that's kind of the directions we do a lot right now. And here's what I want you to simplify. All right. I want you to simplify the sum of those two complex numbers. 5 plus 7i plus -2 plus 6i. All right, so what I'm hoping is that you notice that you have like terms. And that's what you're combining. It's just like if you had a variable instead of the I. So 5 plus a negative 2 is 3. 7i plus 6i, positive 13i. That good so far? Okay. 8 plus 3i minus 2 plus 4i. All right. Alright, so combining like terms again, but this time there's a minus between. So we have 8 minus 2, which is 6. And then 3i minus 4i is a minus 1i or minus I. Okay, don't lose the I. Okay? Alright. So this one. Like terms, 7 minus 3 is what? 4. And then what are we going to have left for that? Minus 2i. Okay. Yeah. And the key is make sure that minus sign goes with the 2i also. Okay. Okay. Hey, I think we've got quite a bit of time. Here's what I'm gonna do today. Let's because I don't think this is something we're struggling with. So instead of starting the next section, let's go ahead and do the assignment that I was going to have you do tomorrow, and that'll give us more time to work on the next section. Because the next section's harder. Somebody's shaking their head no.
There's two.
They what? That's 2 people shaking their head no. All right. So back to page 2 with 74. Let's see how I want to do this one.
We got 19.
I know it's 19 through 27 odd, and then 29 through 34.
So you know. So you know what kind of stuff.
Yeah, 50.
Okay, close.
Yeah, real quick, this 29 through 34 is all of those. 5, those odds on the top section.